I've been at Stanford for 13 years and never thought I would be a part of multiple startup companies.
The challenge is that the fleet of transformer in the US is very old. So the average age is already reaching 33 years. So 65% of the transformer are supposed to be retired by now.
Wow.
I've had these moments in my research career where I'm like, the light bulb's going off. I have to do this. I have to do this now. I'm the one to do this. Let's go for it.
Welcome to the Stanford Ecopreneurship Podcast, where we explore how university research and innovation move beyond the lab to shape real-world climate solutions. I'm your host, Sam McClure. This is our Academic Innovator series, and today's guests are Professor Debbie Senesky and Dr. Joseph Cao, the co-founders of Magnefy. Their company uses AI-powered magnetic sensing to improve power grid resilience and detect failures before they happen. Debbie's lab at Stanford develops electronics that can endure extreme environments, from deep space to high-temperature energy systems. Joseph is a graduate of Stanford Business School with a materials science PhD from the University of California, Berkeley. His experience at companies such as Apple and Meta has helped Magnefy translate lab insights into scalable solutions. We discussed how Debbie's cutting-edge, patented research became a viable startup, the urgency of modernizing energy infrastructure, and how interdisciplinary collaboration drives climate entrepreneurship. Thanks so much for being here. I actually want to start in a much softer place because I'm curious about the beginning. You both work in climate sustainability now by way of materials science, but early on, did you have a consciousness about nature, the environment as a kid, and what was that and how did it come about?
Yes, I can start. In reflecting on my childhood, in the summertime, playing with butterflies and noticing that there's powder on the wings, and then later finding out that the powder actually helps with the vibrant colors of butterflies and actually helps with flight. Those powders are actually little nanofibers that are a part of the wing.
And where did you grow up?
I grew up in Las Vegas, Nevada. So this is, I'm from the desert and yeah.
Yeah, terrific.
Yeah, so for me, I grew up in Taiwan. My grandma actually escaped China during the Civil War and to Taiwan. So she just shared with me a lot of stories on how she utilized resources during the wartime to help herself and the people in her network and the people in the village to really survive. When I first heard about climate or recycling specifically from my grandmother, it's actually about survival. And to some extent, I think that's very relevant to our current situation now. We are really talking about the survival of the human species, right, in the next centuries or so. So she really shared with me how she translates limited resources to useful tools. So Taiwan actually has one of the highest recycling rates in the world. And I'm very proud of that. So that's really an interesting journey for me and opened up my interest in material science to begin with and decided to study polymer science.
So you went into material science with this recycling sustainability perspective already. Yeah, it's fascinating. And island nations have to have a different consciousness around their material use, right? Because they're closed systems. And Debbie, so you had this fascination with the small. So was that all the way through your academic career, or did you take a dog leg left and then come back to nanomaterials and other things later on?
I think my fascination with nanotechnology happened when I was an undergraduate conducting research in a laboratory. As part of that summer experience conducting research, I was able to tour a clean room facility. So I was able to gown up into a bunny suit. I got to see these shiny machines that were used to put down very, very thin layers of films. And also these machines etch teeny tiny patterns into films. A pivotal experience for me was seeing a microchip underneath a microscope, and it looked like a city. So the patterned metal traces, Again, the vibrant colors of the films, the contrast with respect to the bright metallization. I thought that was really exciting to be able to manufacture at a small scale and at a scale at which you can't see with the human eye. And that these little city-looking type structures were actually functioning electronics that can interact with the environment. And so those experiences actually led me to pursue graduate school and conduct a PhD in the area of sensing and microelectronics.
Fabulous. And then you worked in industry after graduate school, right? So could you speak a little bit about that?
Yes, absolutely. After graduate school, I had no interest in academia. I headed straight to industry and worked as a sensor designer at a company called GE Sensing, where I developed sensors for automotive and healthcare applications. And that experience really taught me about commercial products, which I think helps inform the research that I conduct here at Stanford.
Terrific. Well, and Joseph, on your end, material science is really broad, but it seems like power and electricity have been a through line for you. Has that been all the way, or is that, the last 5 years?
Yeah, the last few years, I would say. So I started, as I mentioned, on plastics. So I work on biodegradable plastic and functional polymer materials for electronics. In Apple, I got a chance to advise the battery recycling program. So that's where it just resonated with my upbringing in Taiwan about recycling and this hypothesis on how we can best utilize the resource and maximize the material's potential for a more sustainable future. So it's like an aha moment for me to really go into the energy industry and pivot and contribute as a material scientist.
Yeah, no, absolutely. And I imagine that the work that you were doing at Apple it has tremendous scale and tremendous impact. So, and you were many steps down the line of being an industry leader and veteran. And so why come back to school? You did the MSX program at Stanford, which is the 1-year master's in business administration, right? The sort of accelerated track. So what was that decision-making process like for you?
Yeah, I think you kind of touched on it in the question already. So I realized that it's not just about the technology. It's also the policy, the business model. I think in Apple, we are sheltered by a very resourceful company. So we have a lot of support from different kind of functions. But even at that time, I started to see that to really bring impact at a bigger scale to the world, we really need to understand interdisciplinary research and really bring together different experts in the policy world, the technologists and researchers like Debbie, and or even supply chain. It's just so challenging to bring impact to the world. And even I saw that firsthand when I was in the industry. So that's also where I realized that I think I want to learn more. I want to learn more about how I can use more systematic framework to accelerate the impact.
Joseph, you came to do the MSX degree, and did you meet Debbie on the first day? Never at your time, your time at Stanford, right? I mean, and part of this is like, you're coming in from industry, you have the scientific background, maybe slightly different in that you're not going to be an academic, you probably want to start something, or you have that entrepreneurial mindset. But are you searching for folks like Debbie who are, at the bleeding edge of their technological field and ready to start something? Just speak to that a little bit.
Yes, because I think that's so relevant to this podcast, because that's always my hypothesis, how to translate high impact technology to do something good to the world. So I actually screened hundreds of patents. Even before MSX, I had some hypotheses, and I look at so many patents in national labs and universities. And when I saw this high impact technology program under Office of Technology Licensing at Stanford, I was like, oh, this is perfect for me. It's exactly what I want to do. I want to work with professors like Debbie to translate their research into impact. So so I think we met around like the 3rd, 4th month of my MSX journey, and yeah, and I'm sure we'll talk more about that, but it was, I just got so drawn into her work, and yeah.
So Magnefy, you're working on this project together, and I'm curious if when you connected, this was already somewhere in the back of your minds, or if you thought, hey, we're going to work on this together, and then in the discovery process of that first problem, Magnefy presented itself. So maybe you can sort of speak to that.
It really was a long journey, I would say. Even coming out of my lab, we had a series of patents, about 6 patents that we filed over the course of maybe 7 years or so. And again, I had this very entrepreneurial-minded student, Anand Lalwani, who encouraged me to patent the technology coming out of the lab. And so I became more and more comfortable with that process of patenting the work. And always in the back of my mind, I thought, okay, maybe one day we'll commercialize this. We heard about this high-impact technology fund where we could be coupled to an MBA student and start to look at the potential, the commercial potential for the technology. And so sat down with Anand and said, sure, why not? Let's go for it. And let's really see where this technology can go and if it actually has a footing in the commercial sector. So then we were matched with Joseph, which was fantastic because Joseph has a background in industry, working at Apple, understanding products, where they can go, what are the benefits and limitations. And Joseph also being immersed in the business school and understanding the idea of value proposition. And so this was a wonderful opportunity to really go deeply into understanding the value of this portfolio of intellectual property and where it might go. So the High Impact Technology Fund really enabled us to start to look at that.
Well, and just to be clear, what were the patents in? Like, what was the problem, the underlying problem that was being solved by this technology?
Absolutely. So the patents are related to magnetic field sensing. So any electrified system has a magnetic field around them. So anytime you have a current-carrying conductor, such as a metal trace, there is a magnetic field that is emitted because of that. And so you can detect those magnetic fields with sensors. So you have microelectronics that are sensitive to magnetic fields and can have a change in the electrical response that we can correlate to the magnitude of the magnetic field. So this patent technology was around the ability to detect magnetic fields at very high speeds, because traditional magnetic field sensing technologies are limited in terms of the speed at which you can detect. So that was the value add. And then we also had application-specific patents around a phenomenon called partial discharge, which is a failure anomaly in many of our electrified systems.
You said you were doing due diligence on many, many, many patents. So what about this technology was really exciting to you or this team, Joseph?
Yeah. So my original hypothesis is on diagnostics for end-of-life lithium-ion batteries to facilitate basically the right decision to recycle, repurpose them, or reuse. So I saw this challenge on diagnostics, how we can quickly diagnose the health of even at the cell level of a big, say, battery pack in your Tesla, and then at the end of life to decide what to do with every cell, and rather than just landfill it. So that was my original hypothesis related to my experience in Apple and coming to business school. So when I talked to Debbie and Anand, I was just amazed at this high-speed sensor and so compact and affordable. So Anand also immediately we started brainstorming, and he shared some ideas that, what if we build it into an array so that we can non-invasively test and assess the health of different cells. Of course, it's very early conversation, but I just love the energy of Debbie, Anand, the team, and also the potential fit between this technology and my hypothesis. Because after assessing so many different patents, I think having affordability, compactness, and high speed, it's actually not easy. And Debbie's patent definitely combine all of the important value proposition for any type of electrical equipment assessment and diagnostics. So that's the main reason I decided to partner with them.
So you started thinking about EV batteries and end of life, but that's not what we're solving now, right? So this is what we call a pivot.
It was a
and
pivot.
So I would love it just if you could explain a little bit more about how that came to be. Were you talking to a potential customer? Was it a random dinner conversation? Was it the results of, coffee-fueled late-night research? All the above?
Maybe I can start to answer that. Yes, we focused on battery technologies for quite some time, and I think Joseph conducted hundreds of interviews in landscaping various application sectors. Batteries bubbled up to the top, but we were really trying to understand our value add. And as we mentioned earlier, a key piece of our intellectual property is to be able to detect magnetic field signatures at very high speeds. So this increases your data sampling rate. For battery applications, we didn't find that was a real need. And so we started to talk to the transformer sector, the electrical grid, which I actually had a funded project with industry in relation to that type of technology. And what we found was the light bulbs were going off. You know that moment when you're like, there's something there. And I've had these moments in my research career where I'm like, the light bulb's going off. I have to do this. I have to do this now. I'm the one to do this. Let's go for it. And I think as a team with Joseph, when we were starting to interview companies in the transformer grid space, we just kept hearing, yes, we need high-speed magnetic field detection. Yes, the failure of insulators in the field is a problem for us. So again, this light bulb moment was when we started to identify the pivot.
Yeah, fantastic. And the market is as bigger. I mean, it's a really exciting market and important from a social resilience and climate resilience perspective as well. So that story never changed. I'm curious, there is a moment of founding a company where there's an actual incorporation of a company. There is a division of the equity of that business and roles and responsibilities. And were these, I think for folks who have not been involved in that process before, it can seem very obscure or difficult, or it seems like it happens all at once. But in reality, these dynamics play out over weeks, if not months, right? So I'd love to just hear what your process was for that conversation, and what was that moment where you took the leap?
Yeah, for me, I think that's always the plan. So I always want to found a startup. That's my main leading hypothesis coming to Stanford. But I think, Sam, I still remember I first met you and you invited me to your class back in spring quarter last year. So I think I think this collaboration with you also really helped me to understand the process of incorporation, equity splitting, vesting, the incentive structure, and how to create a healthy co-foundership and also advisorship. So that's just I think that's the beauty of Stanford. And
there's, unfortunately not a 10 bullet point brochure that we hand out to faculty members saying this is how you do this. So I'm just curious, what was your process in information finding and that decision that you made to be an advisor of this business, but remain on as faculty?
Right, absolutely. Again, one of my core goals was to see this technology go out into the real world, and working with the right team and the right way to do that. I actually have another startup company which I co-founded, and so that was also another aspect of, how do we frame it in the right way. And so I have decided to be an advisor to Magnefy. And I think that is really the right framework given just the bandwidth and also the stage of the company as well. So working closely with our mentors here at Stanford and within the entrepreneurial community to really develop a strong team that can pave the way and push the technology forward. I think what's unique about the team is that we're very interdisciplinary. We have the science team, which is my side of the house, and then also the leadership team, right? The entrepreneurial, the business aspect, so working with Joseph and others really to ensure that we have really a team that can help lead the technology and lead the company in the right way. So it's been, I think, very advantageous to have this interdisciplinary team and then also have the resources at Stanford behind us, including the High Impact Technology Fund and the Ecopreneurship program as well. Joseph spent a summer working through the Ecopreneurship program. And there are other local accelerator programs and such that I think among both of us, we've been a part of many of them. And so this has been a learning process. And I think it's a little bit like building the plane as you're flying it and adapting and pivoting. But it's been a great experience so far.
I have to say that sounds extremely reasonable. You know, it seems like it landed in a wonderful place, but these can be hard conversations. So I'm, from the legal end and at the law school, I often receive outreach from folks who say, I would love to start something, either faculty or student. I'd love to start something. My potential co-founder, advisor, whoever is a student or is a faculty member, and they seem like they're being totally unreasonable in their requests for equity or title or control, whatever it is. And those can be really difficult conversations. So I would love to just double click on this for a moment and I'd be curious if you're willing to share, was there a tough moment? Was there a moment where someone sort of had to step back in their expectations, or was there a framework or an argument that ended up being really convincing to the two of you that allowed you to land in a healthy place?
I think we did talk about equity for Debbie's advisorship. So, but I think it's both of us are very reasonable. I think what I really love this team is that our intention is really to commercialize the technology and make impact to the world. So I was also navigating. I look at Carta and other founders' recommendation, and of course, counsel's advice in terms of what's reasonable in terms of equity and the vesting schedule and the period for Debbie's contribution to the company, and share that with her. I think there's definitely back and forth between the two of us, but we're able to land on something that makes sense to both of us. So yeah.
Mm-hmm. Just to add, Joseph's a tough negotiator.
That's good. That's who you want to be leading the company.
And so am I. So you have these two tough negotiators, right? Going like, hey, Yeah. But landing in a place where I think what's really important, landing in a place where everybody's happy. And so, yes, there was definitely back and forth around equity. And also myself taking a pulse at what can I really contribute to Magnefy, given that my role at Stanford, given that I am co-founder of another company, and given the stage of the company, and speaking with mentors, I think at the end of the day, right, we have an eye to making a successful organization and building it and going through a positive journey together. And so I think what I'm really happy about is that, I think we both landed at a place where we're both happy, and I can see it. Once we got through those negotiations, it's like, oh, okay, now let's go. We can let's do the work. And so that's where we are now, and it's been really, really fun.
Well, that's terrific. Well, What does the day-to-day or week-to-week interaction look like between the two? Do you have a standing call? Do you have meetings? What does that look like?
Yeah, we have a bi-weekly meeting, but I think I ping Debbie all the time. And she is so busy, sometimes I even feel bad. But since this collaboration is so close, so I literally just ping Debbie by text. So,
And startups move fast,
Oh,
right?
yeah, I feel like I'm a medical doctor on call, like with the pager, right? It's like Debbie, but that's totally my motto is don't be shy. And so, don't be shy. And this is great. Joseph's not shy. We're always like, okay, this is what's happening. Let's do this. And navigating a lot of the, paperwork process, administrative process of starting the company and starting a company from Stanford intellectual property and navigating those processes. That has been a real process of learning, and I think we've landed in the right place, but also a process of support. Really grateful to Stanford for supporting us in navigating this process. This has been great. So yes, we have our bi-weekly meetings, but then we're also texting each other and then also emailing each other as well. And it's really been a lot of fun.
All modes, all the time. Startup speed.
Mm-hmm.
Yeah. So back to the work itself, right? I mean, you have this very cool new sensor that everybody seems to want you to build, want you to deploy at scale. Like, let's say this succeeds. Let's say Magnefy succeeds and you have an economical unit that is deployed at scale. What's different? I mean, orders of magnitude more data is being collected, right? But how does that enable decision makers or managers of this infrastructure to do better? And what does doing better mean?
I want to take a step back to provide more context about the problem. So the transformer is a very critical asset in the grid. So it steps up and down the voltage. Without transformer, we cannot get the power and energy in the industrial setting or even in our home. The challenge is that the fleet of transformer in the US is very old. So the average age is already reaching 33 years. So 65% of the transformer are supposed to be retired by now.
Wow.
And with the electrification and data center boom, the challenge is that the failure rate will go up. And the fact is the failure rate has gone up 2-3 times in the past decade or so. And on top of that, the reason we decided to pivot is because not just the importance, but also the urgency. So for transformer, the biggest challenge is the supply chain. The lead time is usually over years. Even for the smaller transformers you see on the poles or underground, it takes months to replace the transformer when they're out. But we still want to deliver power, right, to everyone. So the key here, when we saw that aha moment, is how we can use the high frequency sensor with very good bandwidth and characteristics to make sure that we can not just find the potential failure accurately and categorize the fault, but also early. I think this early piece is really important, so that if we can detect the potential failure, that will turn into catastrophic events down the road, months or even years ahead of time. Then the end users, they can be utilities, data center, even hospitals, or even universities like Stanford, to really do the right thing in terms of the maintenance and extend, or just the operation. How we use them to extend the asset lifetime of this type of a critical asset by, say, 20-30%, and even plan for replacement if the failure is just really bad based on our algorithm and projection. So that really helped. That's why it just clicks when we talk to the end users. We hear the urgency there as well, just because of the supply chain challenge.
Right. Yeah. Well, and what would catastrophic event look like, right? I mean, if one of these things fails and they're not ready for it, what's the cost?
What happens is downtime, grid downtime. So anytime you have a transformer that is subject to a failure event, such as partial discharge, They have to send an operator out to inspect the failure, understand where the failure occurred. Is it an easy replace? Do we have to, take down the entire transformer? So downtime, that can cost millions of dollars to the energy sector. And so this ability to prevent downtime, to detect the onset of failure before it becomes catastrophic is important to the field. So this is why the speed aspect of the technology is so valuable. And I personally find it very beautiful as well. It's not only through the materials, the unique materials that we're using that are able to detect this high-speed phenomenon, but it's also the algorithms that we're using. And in today's world with machine learning and artificial intelligence, when we start to couple these technologies together, it's just profound, what the future looks like in terms of a sustainable grid.
Yeah, I also want to add, for example, just a few weeks ago, you saw this incident at London Heathrow Airport. There's a transformer failure. It shut down one of the world's busiest airport for a day. And the Iberian Peninsula's outage, while transformer is just part of the potential root causes, it really showcased how fragile our infrastructure can be. And and this is not something we want to see too often. Yeah.
Well, where are you in terms of the commercialization process? I mean, so you've made this pivot, you've talked to customers, there's clear demand. Do you have a working prototype? Are you producing at scale? Or what is that process looking like right now?
So we are bridging the research laboratory prototype scale and bringing it to the first commercial type prototype scale where it starts to look like a package device in the application format. So we've been working closely with companies to understand how we can take that lab scale device, which looks kind of like a Frankenstein type prototype where you have a chip and then there's wire bonding to a printed circuit board and then you might have an oscilloscope on the side, right? And you're collecting this beautiful data. But how do we shrink that down to the form factor that a company would actually use on a transformer? And that's where Magnefy comes in, where we're starting to really increase the technology readiness level outside of the lab, working closely to understand the sensing needs, the placement needs, and also the form factor as well. So, and cost too. That's something that we're starting to look at. How do we source appropriately in the supply chain as well?
And with regard to funding, because this all takes money, right, to build and design. You had Stanford grant funding to do initial research, but presumably you are moving beyond that and maybe talking to outside investors. So, again, another process that seems sort of strange and mysterious for many faculty and others listening in. So, Joseph, can you speak to what your fundraising needs are? Like, what does that roadmap look like for the next couple of years? And how did you think about pulling those pieces together?
Yeah, I think I actually want to follow the chronological order, and hopefully this can be helpful for many faculty as well, because Stanford is great. There's so much resource to leverage. So I think Debbie mentioned originally we were funded by the HIT program. And after, I think, late last year, we started to think about Sustainability Accelerator, which is a great initiative. I think that we need more platform like that. And also Tomcat, which is perfect for this type of lab to market translation. And we also applied for NSF STTR earlier this year for this translation. So a lot of this non-dilutive grant, I think, is something people like us, trying to translate academic research to an actual commercial product can really leverage without giving away too much equity. But to your point, I think after all, this is a deep tech technology. So
it's expensive.
Yeah, we not only have hardware, we also have software, the AI machine learning. So we actually started fundraising in late April this year. So recently closed to 1.6 million pre-seed fundraising from institutional VC investors. So that can give us around 18 months or longer runway for the next 1.5 years, and really to first translate this into a commercial product and start to collect data and secure sales contract next year in preparation for the seed round in 27.
Yeah, prove that you can build it, prove that somebody wants to buy it, and then you can scale up. Yeah. And does any part of your fundraising strategy have to do with government grants? I know that there's been a renewed focus on American infrastructure, and is there capital available from the Department of Energy, for example?
So through the National Science Foundation, through Department of Energy, there are programs such as the STTR and SBIR programs where government funding is given to small businesses and academia as well when we're in this transition period from the lab to the commercial sector. So this is what Joseph noted, non-dilutive funding, and so we are in the process of applying for those as well. In addition, as Joseph mentioned, Stanford has programs internally that are helping us transition as well, such as the Tomcat Fund, which we were awarded recently. So it's been nice to learn about the different avenues, whether it be non-dilutive funding or venture funding, and coupling those together at the right time. So right now it's a mixture.
Sure. Yeah. I'm curious, in these conversations, obviously you have to make the business case to the investors because they have a prerogative to get a return for their investors, right? And so on and so forth. But impact is top of mind for both of you, right? And so when you go out and have these funding conversations on the for-profit venture capital side or the grant side, where and how does impact show up in that narrative? Is there a metric that you're measuring other than ROI, dollars return, market size, that has to do with impact? Are there some investors that care more or less about impact? Maybe a grant application, it shows up, but not so much in a VC pitch deck or vice versa. I'm just curious, Joseph, how that's been going.
So I think for us, we are lucky because we are tied to grid resilience and data center infrastructure resiliency and efficiency. I think when I first joined before the current administration, there were more VCs and LPs who care about impacts, but currently it's definitely a tougher environment for climate-focused entrepreneurs.
Which doesn't mean that you're not doing the same work. It just means the way that you're framing the problem and framing the solution shifts, right? So that's interesting to navigate. Yeah.
And just to add, I think our beachhead market is the grid transformer market, that sector, but this technology can open up other markets as well. So that's one aspect that we're seeing when we're speaking to venture capitalists, is the potential to penetrate larger markets. And this is something that the technology is a bit agnostic to because it's detecting magnetic fields everywhere. And so I think, although we have this narrow focus right now, the potential to scale, because humans are looking to electrify systems. This is something that I've noted as well.
Yeah, well, maybe keying in on that, if the sensor that you create becomes, which we expect it will, it becomes even 10 times better than it is and 100 times cheaper than it is, right? Yeah. And all of a sudden we can put these sensors everywhere and Magnefy becomes an enormous company. Where do you expect that those market opportunities will arise? Like, what does Magnefy look like? What markets is it in the next 8 to 10 years?
Yeah, we, as Debbie mentioned, transformer is definitely our beachhead market for many reasons. So we definitely want to focus on not just front of the meter in the utilities, but also behind the meter. We really see big opportunities in data centers and mission critical facilities in the CNI, the commercial and industrial setting. So I think that's in the next 3 to 5 years, that's our focus. But beyond that, we also see that it can really start to be used for other electrical assets. So what Debbie can also share more is she has done a lot of work on, say, motor predictive monitoring, and potentially this can be used for switchgear and other critical electrical asset. for our grid and power supply, or even manufacturing. So I definitely see that in the second phase, we can bring this to the manufacturing industry as well, to really help people prevent the electrical failure and make their operation more efficient and decarbonize their operation as well. So from OPEX and environmental perspective, it can really benefit the stakeholders and decision maker operators in manufacturing. I think in the very long term, I definitely see this technology to be the potential go-to IoT device, and also the data to tell the truth of every type of electrical equipment. So for example, even insurance companies or many other businesses could potentially be interested in the data that we have generated with this type of device for, say, risk assessment or other type of business models.
So we're seeing that, right, more generally, that sensors are getting easier and cheaper to deploy, data is being collected at exponentially higher rates, and now we have tools that are ever better to analyze that big data. So that trend will continue, I'm sure.
And just to add, as we electrify the world and we look at low carbon energy systems, perhaps one day Magnefy's sensing technology will be used in a tokamak, right, a fusion reactor. So when we look to the future, it's important that we think about emerging applications, and that's something, if I put my research hat back on, we can start to look at deploying in these types of systems as well. And so electrification is real, right? We have electric vehicles, whether they be drones, aircraft, and then also new types of energy systems are going to use many of the components that we see in grid technology. So it's really an exciting time to be an innovator right now.
Oh, I'm excited.
Yeah.
Well, you've heaped praise, both of you, on Stanford for its support throughout this process, and I think the university likes to think of itself as being very good at this, and I think it is in many ways. But I'm curious, if you wouldn't mind, if Stanford could make one institutional change that would have made this process easier for you, or really supportive and changed your experience. Abby, I'm just curious what springs to mind. Or we can start with Joseph if nothing's on the tip of your tongue.
No, I have it. I think that we really, as a Stanford community, need to tap into these interdisciplinary or radical collaborations, as I like to call them. I would like to see business students working with engineering teams earlier in the process. If I had someone like Joseph, a part of my group, earlier on, we could have launched this technology much sooner. Also, there might be technology in my lab right now that might have opportunities for translation, but I don't know it because I don't have a business student, right, working alongside me. And so I think the programs like the HIT program, Ecopreneurship, this is just the start. I would like to see Stanford really institutionalize this and start to deploy, across campus earlier in the process, and almost, build that team right at the onset and starting to run some programmatic experiments along those lines.
That makes a lot of sense. It's a place where there's a lot of flowers blooming,
yes.
Maybe not so many flowers talking to each other.
But also figuring out that swim lane, right? Joseph mentioned conflict of interest. I had many meetings with the Office of Conflict of Interest, right? Because I'm involved in both the academic research, so how do we maintain the ability to have academic freedom where my students can continue to publish, but also as an advisor to Magnefy, right? How do we ensure that, we don't have a conflict of interest and navigating that in the appropriate way? So that's something as a faculty member I'm just learning about. And so I think educating faculty members about that is really important. And having the right support and programming is really good.
I think the work that you're both doing is really wonderful, but it's difficult, I think, speaking from some narrow experience of myself, is to spend your day thinking about climate change and thinking about sustainability. And the problem is overwhelming, and it can lead to pessimism and cynicism, and it can be depressing, I think. And yet there are lots of places to be hopeful. So I'm just curious, how do you not sort of stay hopeful, but maybe what is something that's giving you hope? I mean, you're working on a solution yourselves, but outside of Magnefy, what's something that's giving you hope about the future of humanity?
I can say that just last week, I helped co-host this Stanford Alumni in Climate Tech event in San Francisco. We brought in several climate tech entrepreneurs and investors to talk about this. I think what I feel very excited is that there are actually still many opportunities. We touch on a little bit about there's policy change, narrative in the public has also changed a lot about climate and climate tech. But I also feel very encouraged about the opportunities actually created by this new administration, and how we can be encouraged to, really look at our business model and technology holistically and create this even longer lasting impact. So yes, it is tough, but I do agree that there's, if you talk it out and really try to connect with other entrepreneurs in the climate space, there's definitely opportunities for you to really find a way to bring your impact to the world. And I was very pumped after the events just to see, even for us, how we can change a narrative. And it's a great opportunity for us to get more connected to the stakeholders, to understand their need, not just on the environmental impacts, but also business. Yeah.
Sure. So that's terrific.
Yes, energy is important for humanity and to sustain human civilization. And so if the technology coming from my research group can help that, I'm very, very hopeful. I think that the Stanford community is really passionate about advancing technology and innovating in different domains. Energy is one of them, as we're seeing, right? The Door School of Sustainability really being a part of the Stanford ecosystem. To paint a vision of the future, would love to see this work really bringing the new data sets that would enable electrification and enable the use of data centers in an energy efficient way, and also enabling new types of energy sources and new types of energy platforms, whether they be advanced renewables or emerging fusion technology. I think that's a real win. And if we can continue to sustain these types of radical collaborations, I think that would be a very positive thing for humanity. And then if I, wear my professor hat again, training the next generation to enter these emerging sectors, whether it be robotics for energy, whether it be AI for energy, or again, the design of new types of power systems and grid systems, I think that's just fantastic and is what keeps me excited about, being a professor and being in research and starting to think about commercialization.
Well, thank you so much. That's a wrap. There's a lot more that I think we could talk about. I'd love to have you here for 10 hours, but we only get one.
Yeah.
So
well,
I
thank
appreciate
you.
the time.
Thank you so much, Sam. This was fun.